So here we are going to see a new topic, transmission media. So what is meant by transmission media? We should have a sender and we should have a receiver. So the data will be transmitted from the sender to receiver using any transmission media. So the physical layer of the sender to the physical layer of the receiver. We may use different types of cables or different types of data to have this one. So the data or compute transmission medium all occupy below the physical layer, and the computers are the used to represent the signals. The signals are transmitted in the form of electromagnetic energies. So the guided medium, unguided medium. The unguided medium is free space where we have the signals, everything. But the guided medium like twisted pair cable, coaxial cables, and fiber optic cables, this will be used here. So the twisted pair cable, what it will do, it's normally consisted of two things. What it will be there, conductors. See here, the conductors and then insulators. You can see here, this is the conductor and this will be the insulators. So this will occupy the places. It will be twisted. Two wires will be the carrier signal, another one is ground. This will be between these two, and the twisting will be increased, and therefore we'll have this data, and the same manner number of twisters will determine this cables. So we have this one twisted pair cable communications. We have this limited bandwidth 1 megahertz and limited data rate, number of data transmitted per second, and everything will have it, and we'll have the data set. So plastic cover and metal STP and UTP. In UTP and STP, we'll have a difference. The meta shield will be occupied in this unshielded and shielded twisted pair cables. So the unshielded sister care advantage is affordable and most compactable cabling, whereas in the network part will be major networking. Suffer from external electromagnetic applications are telephone lines will be considered as application. Whereas the STP will be more expensive, heavier and harder, and it will be easy to do it. And its installation is easy. Distance only it will occupy 500 to 1000, that is 100 to 500 meters. Higher transmission rate faster than UDPs. So that they have given their ranges, how it is categorized, improved connections, and where we use us in this particular location, everything has been given. So most common we will use this one in within the buildings or in the telephone network, and it is cheap and lower data rate. So outer conductor, interconductor, this is coaxial cable. We can have the two insulators. Two insulators is difference when you have the inner conductor and outer conductor. The inner conductor is a solid wire and the outer conductor serve both as a shield and against this noises, and the second conductor will also improve this. The outer conductor is a braided shield and inner conductor is a solid metal, and we have this one. The characteristic is it amplifies every few kilometers closer to higher frequency up to 500 megahertz. It just occupy it. Whereas in the digital signals, it repeats for every 1 kilometers. So application and television distribution, long distance teletransmission for your internet purpose, and the short distance computers, local area, cable TV, wherever we use this one coaxial cables. Next one, fiber optic cables. The fiber optic cables angle of incidence, the formula we need to use it, that one, the ray make its line perpendicular to interface between these two substances. The angle of incidence which provides the angle of refraction of 90 degrees. So less than, greater than, or we need to see refraction, refraction and reflections. So based upon these laws, we are going to use this reflection to guide this light toward the channel. It's a core of glass or plastic surrounded by this cladding, and the cladding has a less dense for the plastic, so it is easy for us to reflect and reflect and reflect. Again, it reaches the destination properly. So the light, it is very cheap and it just occupy the temperature ranges. So light emitting diode and injection laser diode, everything has been utilized here. So we have the modes we need to see here, and the modes we have this one multi-mode and single mode, and we have the step index and graded index. So this one which reaches this one multi-mode and simple mode. You can see here multi-mode, more than one lines are there, and multi-mode with the graded index. We have this destinations, and the multi-mode single source, that is single source. So we have this multi-mode with the step index and graded index. So destination, you can see how it reaches the destinations, how the distortions will occupy the signals. So fiber optic cables, plastics, and the cable bone, we can use it, and it has very good advantage when compared with this previous wires. And the installation and maintenance also a more and much more expensive. We need skilled operators to install this one, but highly secure. Difficult to tell you, lack of signal radiation and all will be less when compared with other signals. So unguided media, we have wireless transmission. The range starts from 3 to 300 and we have the data to be transmitted. Occupy within the ionosphere. So very low frequencies, middle frequency, we have it. So long range radios, FM radios, satellite communications, everything we will use it. Next one is your radio waves. So the radio waves, microwaves and infrared medium, we have it. So in this radio waves are usually for multicast communication. They can penetrate through walls and it has highly regulated. We can have this one. And the microwave is for unicast communication, mostly used in cellular and satellite. We have that high ranges that cannot penetrate the walls. So micro communications for a radar purpose and other those things for we will use this for military application, other things. So overall, we have just concluded with guided media and unguided media.